In this module of Chapter 3, Module 3.3, I will cover continuous mortality, including the force of mortality and smoothing. Consider the number of survivors at each age, Lx, as a continuous function of age x. Then the force of mortality is defined as the ratio of the rate of decrease of Lx, that is the instantaneous effect of mortality at that age, to the value of Lx. Algebraically, we define this as mu x equal the dividend of the difference between Lx plus 1 and Lx. This can be given as this expression where ddx represents differentiation with respect to age, which indicates the rate of change of Lx over an infinitesimally small increment of age. The minus sign is introduced to make mu positive since Lx is a decreasing function of age. From basic calculus, the derivative of the natural log of a function of x, log fx, is given by this expression at the top, which can be defined at the bottom as mu x, which equals ddx of log Lx. Integrating both sides from 0 to n yields the right-hand term in the second set of equations, where the integral equals minus the log of Lx plus n divided by Lx. This in turn gives the survival npx from x to x plus n, and the exponent of the expression inside the brackets as shown in this bottom equation. If n equal 1, then this expression can be simplified as age-specific survival px equals e raised to the minus mu x. This in turn can be given as log px equals mu x. And as we know from the life table, age-specific mortality qx equals 1 minus this expression. Thus Lx equals the exponent of the summation of mu x's from 0 through x as given here. The force of mortality can be thought of as a measure of mortality at the precise moment of death, or as the first derivative of the Lx function. In actuarial modeling, the force of mortality is preferred over age-specific mortality qx because it is not bounded by unity, it is independent of the size of the age interval, and it forms the argument of numerous parametric mortality functions or models. Three formulae that are commonly used for computing mu x include mu x equals minus the log of age-specific survival px, mu x equals the mean of the sum of the log p x minus 1 and the log of px, and mu x equals the expression on the right that uses Lx values over large intervals, age intervals from x minus n to x plus n. This ends Module 3.3 on continuous mortality.